So here we're going to start to tackle some of these problems without a calculator. And in doing so, we're going to hopefully learn a little bit more about the relationships between derivatives and integrals. So we have, our friend is skating here. We're given velocity, and we're asked for displacement. So displacement, as we remember, is the total change in position, right? So how far did we move from 2 to 5? So to answer this question, we need an integral, right? I'd say my displacement d is equal to the integral from 2 to 5 of v of t dt. So it would be the total change in position would be the integral here. Now, previously we would have just typed this into our calculator, put in the bounds, and it would spit out a number for us, and we would be done, right? Here we're not going to do that. We're going to do it by hand. And there's two reasons for that. The first is just that the AP exam does not allow a calculator on the entire test, so only some parts of the test. And then the second and the more important reason is that this is going to allow us to see the relationship between the integral and the derivative a little bit better. And also answer some questions we couldn't answer before. So what I'm going to do here is just I rewrote the integral, and instead of using v of t, I used the whole function v. So I rewrote it as the actual formula for the function. And now I'm going to take what is called the antiderivative. So that looks like this. So I'm going to do just the first term. So negative t squared becomes t to the third times 1/3. And the reason for that, if you think about it, you'll understand the reason for that based on what you know already. So the reason for that is when I take the derivative, I multiply by that power, and I subtract 1 from it, right? Here, I'm doing the opposite. It's the antiderivative. We talked about how integrals and derivatives are opposites. So antiderivative means I add 1 to the power and divide by the result, right? So the reason I need to divide by that result is because when I take this derivative, I would do times 3, canceling out the 1/3, and then subtract 1 from it. So if I took the derivative of this, my 1/3 t to the third, I would get my t squared, right? So that's what I'm doing. I'm doing the opposite of what we've done before. 6t, well, I would need a t squared to get a t, right? And then I would end up multiplying times that 2. So 6 divided by 2 is 3. And you can check if you took the derivative of 3t squared, you get 6t. And then 1, well, t has a derivative of 1. So that is my antiderivative. Okay, it's the opposite of what we've done before. Okay, and now I don't want to write this integral sign anymore because I've taken the integral. Just like when you add two numbers, you don't write the plus anymore after that, right? But I do need to represent this 5 and the 2. So we haven't done anything with that yet. So I'm going to draw this straight bar over here and rewrite them. So to keep track of what my bounds were. And then, just like if I asked you what was v of 5, we plug it in. We're going to plug these in here. But the way it's going to look, we have two numbers. So we're going to plug them in twice. So I've plugged in my 5. Now I'm going to subtract. I'm going to do the whole function again. But this time, I'm plugging in 2 for t. Okay, so this is going to allow me to evaluate this integral. And notice I put parentheses and subtracted the whole function again. And we'll talk about why we do that here in a second. So what I get here, and you could check on your calculator, is 27 meters when I do all this math here. And then the reason we subtract these two numbers is, remember, what we're doing is we're doing area under a curve, right? So if I draw a little sketch, if we want this integral from 2 to 5, well, it makes sense that I would take the entire integral all the way to 0, right? and then I would subtract that second part, right? So if I want just this area, what I'm actually doing is finding the area all the way to 0 and then taking out the part that I don't want. And that's my blue area here is that area. So that's how you do this by hand. You take the antiderivative and then you evaluate the bounds. A button on my calculator would spit out the same thing, right? So now here's a question we could not answer, but before it asked me, what is S of t? What is a possible S of t? Well, S of t, it's what we just got, right? It's the antiderivative of v. Because we know that velocity is the derivative of position, so it makes sense that position would be the antiderivative of velocity, right? Here's the catch though. So notice I said possible function. So if I wrote plus 5 at the end here, that would be a possible function for S of t, because the derivative of this, well, the derivative of 5 is 0, right? So that would still get me my v if I took the derivative, and you can check if you don't believe me. If I put plus 10, still true, right? Still a possible function. So the answer here, there's an infinite number of possible answers here. And the way I represent this is I'm going to say plus c here. So plus c, c stands for constant. So it's any plain old number I could add here, and it would still be an antiderivative of v, right? So we don't know the exact answer here yet. And yes, if you forget to put the plus c on a problem like this, it is wrong, because we do need to represent that it could be many different things. Now, let's answer our last two questions, and maybe we'll see what we can do with that c here. So here the question is, where is she at t equals 5? And we're given s of 2 at time 2. Her position is 2. Well, we know that her position is going to be at 5 is going to be her position at 2, which is 2 plus the integral from 2 to 5 of v of t dt. So that's the integral we found before, so this is really just 2 plus 27. So it's her starting position at 2 plus the change from 2 to 5 is 29 meters. All right. Now, we know a little bit now about S. We have what is called an initial condition. So without this, we did not know enough to figure out my function S, but now we do, because we know that S of t is equal to negative 1/3 t squared plus 3t plus t plus c, and we know that S of 2 is 2, right? So that means 2 is my y value, and I can plug in 2 for my t as well. And then I have an equation that I can solve. So this lets me solve for that plus c. So now I have an equation with a variable in it that I can just simplify and solve, right? So I get 20 over 3 plus c. And then when I subtract 20 over 3 on both sides, I get negative 14/3. So that gives me my full function for S. So this is the problem that we could never have done before this lesson. So my whole function, S of t, is that integral that I took before minus 14 over 3. So the way I got that, right, is by plugging in a point. So I plugged in my initial condition and solved for c. This, by the way, is called an indefinite integral.